Welcome students. Till now we discuss combustion and flame. We learn that definition of combustion. Combustion, it is a process in which the combustible substance is burned in presence of oxygen. Such a process it is called as combustion. Combustion may occur in presence of complete oxygen supply or in presence of incomplete oxygen supply. If oxygen supply is complete, then it is called as complete combustion. If supply of oxygen is in sufficient amount, then it is called as incomplete combustion. We also discuss definition of ignition temperature. Ignition temperature, it is the lowest temperature at which substance can catch a fire. Example is phosphorus. It can catch a fire at a room temperature, that is at 35 degrees Celsius. We also discuss calorific value. Calorific value, it means how much amount of heat is get liberated when 1 kg of substance is burned in presence of complete supply of oxygen. Calorific value of hydrogen gas is very high, 141.9 kilojoule per mole. This is a value of hydrogen gas. Today we are going to discuss next part of the topic. In that you can see requirement to start a fire. Student, please tell me what are the requirements are required to catch a fire? Yes, first is combustible substance. We require substance. Second is oxygen is required. Without oxygen it is not possible to burn anything. And third one is the ignition temperature, or we can call it as a heat. It is also required. When we summarize all these three substances, these three parameters, then we can say that substance it can easily burn. See, three essential requirements of producing fire. Can you list these three requirements? Yes. First is fuel, second is air, and third is heat. Obviously, heat is nothing but the ignition temperature. Fire can be controlled by removing one or more of this requirement. If we want to control of the fire, you can control on any one of the factor which is mentioned above. The job of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel. In the both way you can control on the fire. It means you can cut off the supply of air, and second you can decrease the temperature of the combustible substance. And notice that the fuel in most cases cannot be eliminated. For instance, a building catches a fire, so it is not possible to remove the building. Okay, this thing is very good for those the substances which are present in a small amount, like paper or small wood. But if building catches a fire, then it is not possible to place a building from one place to another place. So remaining two factors you have to be focused, you have to be controlled on it. Next, so how we can control over on the fire? Yes, fire extinguisher. So different types of fire extinguishers are there. Water fire extinguisher, soda acid type of fire extinguisher, or we can also say that acid base type of the fire extinguisher. So how these fire extinguisher play important role on the control of fire? The most common fire extinguisher is water. This is a common. If we don't have anything, then simply we can use as a water. But this water works only when The things like wood or paper are on fire. For these two kind of the substances, then water it is good. But if electrical equipment is on fire, so we cannot use water as a fire extinguisher, because water itself conduct electricity and there may be the cause of any hazardous incidents. So water is not suitable for this. At the same time, water is also not used for petrol, kerosene, which catches a fire. Why? Because if we know the density concept, that is a mass upon volume concept, the density of petrol, kerosene, oil is very less. When we poured water on it, water molecule, it will be settled at the bottom, and petrol, kerosene, it will be float on it, so it will not be covered. If it is not covered, it means oxygen, it will be help for spreading fire everywhere. So in this case also, we are not able to take water as a fire extinguisher. So what option we have? So for fires involving electrical equipments or fires on inflammable substances like petrol, kerosene, oil, we have the best option is carbon dioxide fire extinguisher. Why this is the best one? Because when we switch on the knob of the fire extinguisher, carbon dioxide, it will be get evenly spread and it will cover all combustible substance on which fire is catched. So it acts as a blanket, and this CO2, it avoid direct contact of oxygen with the fire. So this is the best mechanism of carbon dioxide as a fire extinguisher. Apart from this, carbon dioxide also decreases elevated temperature on the combustible substances on which fire is catched. So this mechanism you can learn in the next slide. Since the contact between fuel and oxygen is cut off due to the CO2 gas is evenly form a blanket on the combustible substance. The added advantage of carbon dioxide is, in most of the cases, this carbon dioxide gas is not harm to the electrical equipments, because if we use water, then there may be the certain damage may occur in electrical equipment, but this is not in the case of carbon dioxide as a fire extinguisher. So how do we get the supply of carbon dioxide? Do you know? We have the LPG cylinder in our home. Initially, it is a gas, but when we compress it, when we apply pressure on it, this gas is liquefied and called as liquefied petroleum gas, that is a LPG. In the same form, CO2 gas is filled under cylinder under pressure. So what happens when we release pressure from the cylinder? CO2 expands in a large amount. So due to the expansion, it cools down the temperature of the surrounding and decreases the ignition temperature, and at the same time we know that it forms a blanket over the combustible substance. So that's why it is an excellent type of the fire extinguisher. Which type? Carbon dioxide type fire extinguisher. It is a good one, it is the best one. Next is types of combustion. We know how we can control a fire with the help of carbon dioxide as a fire extinguisher. Now we also know, is there any type of combustion is there apart from complete and incomplete combustion? Yes, combustion we can divide into so many types. First is rapid combustion. So what is mean by the rapid combustion? Rapid combustion means, do you know, when we try to burn any kind of the candle, it can catch the fire immediately. It means that this type of combustion, it is called as rapid combustion. When we switch on the flame of a gas burner, it will catch a fire immediately. So this is an example of rapid combustion. What is the main headline of this type of combustion is, in this type of combustion there is no any time lag between when we ignite a fuel and it will catch a fire. They will immediately burn and form a flame. This type of combustion is called rapid combustion. Second type of combustion you can see in this side, you can easily observe. Bring a burning matchstick or a gas lighter near a gas stove in the kitchen, turn on the knob of the gas stove. What do you observe? We find that gas burns quickly and produces heat and light. So this type of combustion is called as rapid combustion. Second type is spontaneous combustion. What is spontaneous combustion? Some substances, when we keep as it is, they will automatically catches a fire without application of heat. Such substances has very less ignition temperature. Example is phosphorus. Phosphorus, it can catch fire at a room temperature 34-35 degrees Celsius without application of heat and the ignition temperature. So at this temperature they can burn on their own without application of heat. It's called spontaneous combustion. And phosphorus is the best example. You can see there are substances like phosphorus which burn in air at a room temperature, and the type of combustion in which material suddenly burst into flames without application of any apparent cause is called as spontaneous combustion. Another example is coal dust. It also results in many disastrous fires in coal mines. Do you know, sometimes we also observe that forest catches a fire, and this fire, it is continuously spread over all areas in forest. So there may be the cause that if we go as a campfire in a forest and if it is failed to extinguish the fire before leaving that particular spot or a picnic spot, maybe the chances that this small amount of fire it can spread all over the forest. So here much more important precaution you have to be take is that we should not be avoid the campfire or any area which is live as it is. You have to be ensure each and every area it will be extinguished before leaving a forest after a picnic or a visit. So in this point we cover second type of combustion is spontaneous combustion. Then third type of combustion is explosive combustion. Do you know that in a many festival we are used different firecrackers. So these firecrackers are under the category of explosive type of combustion. So we generally have fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light, sound, and a large amount of gas is liberated after the reaction is occur between these two. Such reaction is called explosive reaction, and sometimes such explosive reaction is also takes place when we apply a pressure on the crackers, because when we apply the pressure then its friction is going on. When the friction is going on, then due to the energy there will be the chances of blast may occur. So to avoid this, never applied pressure on the crackers. So in this way there are three types of combustions. First is rapid combustion, second is spontaneous combustion, and third is explosive combustion. I hope each and every point is clear. Next point is flame. What is flame? Flame, it is a visible part that is easily observed through our naked eyes, which contain different zones or parts. Observe an LPG flame. Can you tell the color of the flame? What is the color of that flame? Then color of the candle flame. If you observe, please record your observation. Where the color of the flame it is same everywhere in each region? No, the color of the flame is not same in each region. So why the color is not same? Before that you have to see one activity. Light a candle. Hold a glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. Do you see a flame? If see, what is it that produce a flame? Notice that the wax near the heated wick melts quickly. Whatever the wax near the heated wick, it melts quickly. Why this is happen? Because wax gain the heat energy from the flame. So what happened? Due to the gain of heat energy, wax slowly melts and it forms vapors. And these vapors, they can catch a fire and they also burn with a flame. You can see one end it is burned in a candle and another end it is burned with a simply matchstick. So whatever the one end of the glass tube it forms a black spot or black particle. So what is the name of that black particle? You can see observation is the substances which vaporizes during burning gives flames. In this process also, wax is burned with a flame because it forms vapors, and these vapors they catches a fire and they are made easily. So what are the different substances? They can form vapors and they burns with a flame. Example is kerosene oil. Second is molten wax. So molten wax rise through the wick and are vaporized during burning and form of flames. Charcoal, what happened with the charcoal? It will not vaporize and not form flame because there is no any vaporization of volatile oil present in the charcoal. So that's why charcoal is burned but without a flame, and candle is burned with a flame. So this is the difference between substances which are burned with a flame and substances which are burned without a flame. Next part, when the candle flame is steady, it means in a constant state, introduce a clean glass plate or slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 10 seconds and then remove it. What do you observe? We observe that a circular blackish ring is formed on the glass plate or slide. It indicates deposition of unburnt carbon particles present in the luminous zone, and these unburnt carbon particles they are called as a soot. Next is hold a thin long copper wire just inside the flame for about 30 seconds. Notice the portion of the copper wire just outside the flame gets red hot. Does it indicate that non-luminous zone of the flame has a high temperature? In fact, this part of the flame it is the hottest part. So in this part, you can realize that there is a certain area of the flame like a luminous, non-luminous zone. They contain a hottest region or the lowest region of heat. So this non-luminous zone has a high temperature and called as hottest part of the flame. You can see structure of the flame. Outer zone, it is a complete combustion. Then middle zone, it is a partial combustion which is yellow in color. Outer zone, it is a blue in color, and innermost zone, it is black in color, and it is a incomplete zone which is used for the formation of black or soot particles. The hottest part it is a obviously outer zone, the moderate hot is middle one, and the least hot is innermost zone. Diagram and its explanation along with their zones is very important part for your exam. Next is, what is a fuel? Fuel is a substance which form light and heat energy which is used for the domestic and industrial purposes. It is called fuel. So What substances generally we are called as a fuel? If they produce heat and light, then we are called as a fuel. For example, wood, charcoal, petrol, kerosene, they are called as a fuel. But which one is a good fuel? Good fuel is the one which is readily available, which has high calorific value, which produces large amount of heat, and good fuel, we can say that fuel which does not form any kind of the residues, does not form any undesirable substances. So these kind of fuels are called as an ideal fuel. But there is probably no fuel that could be considered as an ideal fuel. So we should look for a fuel which fulfill most of the requirement for particular use. No one is the best one, but we should try for the best one. That is the fundamentals of these points. Next is fuel efficiency. What is fuel efficiency? Suppose you were asked to boil a given quantity of water using cow dung, coal, and LPG as fuel. Which fuel would be prefer one? Give your reason. You may take the help of your parents. Do these three fuel produces the same amount of heat? No. Different substances produces different amount of heat. So the amount of heat energy produced on complete combustion of 1 kg of fuel is called its calorific value. The calorific value of a fuel is expressed in unit called kilojoule per kg. How much amount of kilojoule heat energy is produced when we burn 1 kg of the substance in presence of complete supply of oxygen. This is called as fuel efficiency. Next part is calorific values of different fuels. You can see cow dung, wood, coal, petrol, kerosene, and etc. You can see hydrogen, it is a 1,50,000 kilojoule per kg. This is a value. So we can say that it is the best fuel, but there are certain limitations for hydrogen gas. Because it is a gas, it is very difficult to handle for the domestic purpose, and at the same time it is light in weight. So that's why it is not easy to control. So that's why hydrogen is not conventionally used as a domestic fuel, because it is highly reactive. But in a liquid hydrogen we can use for the fuel engine in the rockets and the jets. This is nothing but the calorific value. So in today's lecture we learn requirements for combustion, that is combustible substance, oxygen, and ignition temperature, types of combustion with their examples, then different kinds of the substances we are used as a fuel. We also learn calorific value, its definition, and calorific value of the sum of the different substances. Fire extinguisher, its role, types of fire extinguisher, what kind of the fire extinguisher it is used for, or what kind of the combustible substance. So this is nothing but the today's lecture. Remaining part of the topic we will see in upcoming videos. Okay, thank you.